Hello everyone, my name is Artyom. There is a common wisdom that every software engineer should write a compiler and a ray tracer at some point in their life. I happen to work on two compilers and actually written a toy one myself. There is a video series on YouTube about this. Check it out if you're interested. With that said, I think the time has come to write a ray tracer. And I figured I could do it in OCaml. Why not? So there's this amazing book called Ray Tracing in One Weekend, where the authors implement a simple but working ray tracer in a small amount of code. So I plan to follow this book, but write OCaml instead, try to write idiomatic OCaml instead, and just see how it goes. So the plan for this video is to set up the project and the environment so that when we make changes to the code, we can see the results more or less interactively. Cool, so without further ado, let's roll. All right, let's start with some basic project setup. Let's create a directory for the project. I'm gonna call it race, nice and short. And I usually like to have an OPAM switch per project, so that's what I'm gonna do now. I'm just gonna OPAM create, I think it's switch create. And I'll be using OCaml 5.0 because I want to be able to use multi-threading potentially later on to speed up the rendering process. But for now, let's just create a switch. Cool, so now let's install Dune. All right. And what I'm gonna do now is use dune init project command to just get the scaffolding of the project in place. So we'll generate a project inside the race directory. All right, looks like we've got a bunch of stuff generated for us. One thing we need to do is to do git init so that Emacs knows that this is the root of the project. And let's also create git ignore. So build and OPAM. All right, so if we just take a look at the lib directory, there's nothing there. Test has just one test file, empty. Okay, and bean has just again one file called main, which is pretty much hello world. Okay, I'm not sure what's up. All right, so let's indeed try to call dune and see how it goes. Okay, all good. Let's try to execute the binary. We've got hello world. And just to make sure that we have LSP. Yep, we have LSP support. All right, this is very nice. I think we're done with the basic project setup. Now let's take a look at the book to get a better feel for what exactly we're gonna do. So first part of this book, second chapter basically, it's about outputting an image. So we'll be building ray tracing. It is important to be able to create an image. And there are a bunch of formats, but the authors suggest using PPM format because it's very straightforward. It's plain text. You just output a couple of numbers here, like the P3, then columns and rows, maximum number for color, and then the RGB triplets. And that's pretty much what is happening here. So the author is creating an image 256 by 256 in PPM format with some weird gradients. So that's what we are gonna try to do as well. Let's switch to the library folder and create race.ml. One thing I want to change as well is the test folder. So in the test folder we have just the test stanza, but I would like to use inline tests with ppx expect, and for this to work we need to change things a bit. So we need to use the library here. We're gonna call it race test. Then we need to say inline tests. I think that's gonna be like this. And we finally need to install ppx expect. Meantime, I'm gonna rename this file to race test. And let's try to run some initial expect test and see whether it works. Is it expect test? Okay. All right. So these seem to have worked as the auto promote. And here we have it. Okay, cool. So now we have inline test with ppx expect setup. Let's switch back to race.ml. And what I would like to start with is with the image module. So I'm not going to do some big brain design here. So let's say our image is just a bunch of pixels. So we have a pixel array, and that's pretty much it. Now we need to define this pixel, and for this I'm gonna use another module. So our pixel is basically gonna be just a triplet, red, green, and blue, where each component is just 1 byte from 0 to 255. So although we don't need it right away, we could just use, let's say, something like red, green, blue. That would be a bit wasteful in a sense that we're gonna be using a record with 3 ints, which is gonna take, so only these 3 is gonna take like 24 bytes, which is just wasteful. We need just 3 bytes, we take 24 bytes instead. So let's just use the single int and encode the color. Let's create another function called create. It will accept a tuple with RG and blue channels. So let's do the encoding. The idea is to just basically do so red, green, and blue inline inside a single int. So let's start with R. Because this is an int, so it can be any value, let's make sure that it's within the range 0 to 225, and let's shift it by 16. Let's do the same for green. Shifted by 8, and finally blue. All right. So let's see. Let's open. Let's add the race library to expect tests. And what I would like to do is to just start this in watch mode with auto promote. Yeah. Okay, so let's open the race module here, and I'm not sure what is it I'm happy about. Unclear. Anyhow, so let's create a some pixel, and just let's start with the just a black pixel. Another thing I want to do here is create the accessor functions like R, G, and B. So in order to access red channel, we just take our number, shift it right by 16, for the green, we do the same thing, but we shift it right by 8, and then we mask the first 8 bits, and for blue we do the same, masking. Okay, cool. So now we have accessors. Let's also implement a pretty printer, and we're going to be outputting numbers in this ppm format. So maybe I just call it ppppm. Why not? And I just like a little bit of abbreviation. So here we start with the just R, G, B. Here, let's do the same. Let's output our pixel here. And let's run the tests. All right, here's a bug. Cool. So now we have the 3 zeros in the output. This is great. Let's create another pixel. Let's say with numbers 10, 20, 30. And do the same thing. Ten, 20, 30. That's great. So now we have our pixels. Let's get back to the image function. Maybe we will start with just implementing the function to pretty print the image in this ppm format. So if we just switch back to Firefox, the format is the following. We have P3 first, then columns and rows, then 255, and then RGB for each pixel in the image. All right. So we start with P3, then we have columns, rows, then we have 255. So we need columns and rows. All right. And then we just output RGB for every pixel in the image, starting with rows. All right, so this looks good. Now let's create another thing, a function to actually create an image. So we need a height and a width of an image. And then we need a function f that will accept row and col and then output a pixel. That's the idea. And for this, we are going to be using, what is this function called? Make matrix or something like that. Okay, make matrix. And in fact, what I'm going to do now is open stat labels module, because I just like having labels on my functions. Which is especially helpful here because otherwise we would have just a couple ints. Now we know that the first one is dim x, the second one is dim y, which is great. So let's start with dim x. That's width, height. I would like to pass a function here to initialize every pixel, but it's not there. So perhaps instead we could use the following. Let's define 0 pixel here. And provide it as the starting value. And then we're just gonna do the same nested for loop to initialize all the pixels. Oops. All right, sounds good. So let's create another expect test here, where we would create an image. Let's say height would be 2, width will be 3, and the function will just do something like that. All right. All right. Oh, of course. So we have to return pixels here. Sorry, not even pixels, but the image. So like this. Okay, and so it seems that we have an array index out of bounds exception. Let's see, height width. Perhaps this is the problem. Maybe these got mixed up. So let's see. How about this? All right, so this seems to have worked. One thing we're missing is the new lines. Okay, so this looks perfect. So now we have 3 columns, 2 rows, 255 for the maximum value of a color, and then we have 1, 2, 3, 4, 5, 6 pixels. Awesome. And you may have noticed that as I was doing the changes, the ppx expect, like the expect test output, was updating pretty much real time, which is just amazing. This is one of these features that I'm really missing in other languages. And yeah, I just love ppx expect and line tests. All right, so if we switch back to Firefox, we will see that the author is generating this type of an image. Okay. Cool, so let's do some scaffolding here. So let's define a function called sample image. For now, it is just gonna create an image like 1 by 1 with some pixel inside. So image create, height 1, width 1. And we also need to open arrays here. Oh, of course. Okay, cool. And so what I want to do now is to create a file, output the contents of the image into this file, close the file. That's going to be the body of the main. So let's do this. We don't need this. All right, let's create an output channel. We're gonna open it in text mode. Let's call it sample ppm. And then we are going to create a formatter that's gonna write into this output channel. So then let's create an image. Then we are going to write the contents of the image. We're gonna close the channel. Let's also maybe write that the image has been successfully generated. Is it 1 or 2 else? And if there is some exception, let's just write some information about this exception into the standard error. So for this, we're going to be using print exception to string. And we are also going to close the channel if it hasn't been closed, but we're going to ignore any errors. And for this, we have this function close no error. And that's pretty much it. Seems that it has executed just fine. So let's try to open this sample.ppm. Interesting. It says for some reason that it's the file is empty. How about we just make it, let's say, 200 by 200. All right. Now this is much better. So we have this image in Emacs, and it's going to be updating automatically while we change the code here in the main. So let's implement the logic that the author has here. And for this, we're going to be doing, let's define the render function. That's going to have a row and a column, and it's going to output a pixel based on this. So so here we have this code. Let's replicate it here. Okay, so let's define image width is gonna be 256, 256 as well. Okay. For G, we're gonna use column, and here it should be height. For B, we're gonna use 0. And we also okay, so there's this thing happening here. So basically our color here is from 0 to 1, and we scale it to from 0 to 255, something like that. Let's do this. Okay, and let's make it a factor. Let's see how it goes. And this is it. Let's see. Does it match what the author has? Yeah, looks like it does. And I guess like the best thing here is that as we make changes to the code, let's say let's make it 0.1. The image will regenerate pretty quickly, and we'll see the updated results. Well, maybe not so much difference here, but let's say 0.9. Now that's very different. 0.1. All right, so I guess this is a very good start. And I guess the plan for the next video would be to, we don't need progress indicator. All right, so there's some fun stuff going on here with the viewports and then the cameras and whatnot. But the end result is this gradient. All right, this is it for the first video. Admittedly, there hasn't been much progress on ray tracing, as there has been no rays and no tracing so far, just a static image. But this is the start. I guess one thing I wanted to say is, what I like about this setup is how interactive things are. When you have Dune in watch mode, updating your tests, and you see the result right away, or you make a change to the code and you see a regenerated image in a matter of seconds in your editor, that's just wow. This is a really awesome development experience. And so I hope that it's gonna help with the rest of the videos to, spot the bugs quickly, see the result of your actions and changes quickly and interactively. But that's it for now. I hope that was interesting, and see you next time. Peace.